Hey guys, in this tutorial we're going to cover signals and events. Signals and events are great ways for you to be able to communicate between different flow scripts. Alright, so let's just start by setting up some basic objects. Let's create a square and let's create a circle. And what I want to do is I want the circle to fall down on the square and do some behavior like change color or something like that. All right, so first of all, what we're going to have to do is add a rigid body 2D and a circle collider to our circle. That will make sure it can fall down. And on our square, we will also add a rigid body 2D. We'll add a box collider 2D. And we'll change our rigid body to be kinematic instead of dynamic, just so that this does not fall. And if we press play, there we go. It basically falls down, hits the square, but there's no behavior. So by using signals, we can add some behavior. So first of all, let's make sure we add a FlowScript controller. All right. And what I want to do is I want to create a signal. So inside FlowScript, if I press space and type in signal, you can see I have a signal callback or an invoke signal. All right, let's just make both of those for now. All right, so invoke signal is what we want to call when we are sending the signal out, and our signal callback will receive that signal, and we can do what we want with it there. All right, so in this case, our circle actually just wants to send a signal out, and our square wants to receive the signal. What you can see here is that we need a signal definition. So a signal definition is actually an asset that you can create by right-clicking, pressing create, paradox notion, canvas core, and signal definition. So let's say circle hit. All right. So now what we can do is put that signal inside here. And let's put it inside here. So actually we could also, instead of creating that node and then assigning it, we can press space, search for circle hit, and it's actually right here. You can click that there. Or we can drag circle hit in and we can add it here directly like this, which is very convenient. And obviously you can do it for the signal callback as well, just like that. All right, so now we have our invoke signal and we have our receive signal. So our circle here needs some kind of event to be called for it to actually invoke that signal. And what we're going to do is we're going to use collision 2D event. So when we enter a collision, we are going to send a signal to whatever we had entered to invoke this signal here. So in this case, when this circle enters the collision of the square, we're going to send the signal circle hit. You see here, circle hit. And we're just going to change the color of that square. So let's grab our sprite renderer, set color, and we'll set it to this nice blue here. All right, and let's run it. There you go. So it hit it, it invoked this. Show you again. So it invoked that signal, and that signal got received here, and it set that color. So when you call a signal, you can actually pass in data. So here you see there's actually nothing here except for the target. But if I click on my signal asset, you have this add parameter here. So I can add a parameter, and let's say here, I'm going to add a color parameter. Now, when I click this invoke signal and press refresh, you see now I can actually put a color through the signal. All right, so let's just make a constant. Okay, there we go. And on the other side, where we receive that circle hit callback, press refresh, and you can get that color directly out and plug it into there. Okay, so that means that, for example, I'll make another circle. Actually, you know what? I'm going to make a different shape. So I'm going to make a triangle. Okay, and I'm going to do this, and let's just make our square a bit longer so that both of them can hit it. So let's make it 5. All right, so what I'm going to do is basically when the circle hits, it's going to change to whatever color we decide from the circle. All right, and you know what? We're going to change this circle hit to be called shape hit. And what you'll see is that it actually updates nicely here. So this is really good compared to hard-coded string identifiers for functions because it updates based on the asset reference. So now if I look in my triangle, which actually I want to copy this over, so copy this, create a FlowScript controller, create a new bound script, paste these nodes, invoke a signal shape hit, and when this shape hits, we're going to change it to be blue instead, or let's make it pink so it's more obvious against this background. Good, and we have to remember to add our rigid body. So rigid body 2D and our collider, and we'll just make it a box collider, doesn't matter. So now we've fed that in. If I press play, it changed green when the circle hit, and it changed pink when the triangle hit. So that's basically how to use these parameters. Compared to a function, it's very easy to use because as you add parameters and you refresh, you actually see the type of the parameter directly, compared to if I were to call a function like this or with the parameters. You see here, I can expose the parameters, but I don't actually know what type they are. I don't know what they're expecting. And so using signals instead make it a lot safer, a lot more obvious what you're working with. So what you can see here is that we actually have a target mode and a target. So let's look at single target for now. So when it's single target, it means that when this single target, the single transform receives the signal, then it will call this. Okay? It means we can kind of delegate that signal callback somewhere else. So let's say I have a second square, and this one is just basic. I don't have anything on there. And let's move this square down here like that. Okay, so right now, if I play, it hits this and nothing happens, okay? But if I go into here and I change that target to be this square, right? So the second square, this is this square here. You see when it hits this, it actually sends a signal to that target instead of myself. All right, so this can be useful for when your hierarchy doesn't exactly match what you need to do. So like if there was a collision with something, but the actual collision object doesn't have the flow behavior on it, you can delegate that to something else. All right, and you see here, we can also do multiple targets. Let's just do 2 transforms. So I want to say, so when this square here hits this square, or, and let's make a different one, or it hits this square, then I want it to send that callback to this object here. So we have that one, and if I move that circle across here, there you go, it works nicely. All right, so let's just put it back to how it was. All right, and now let's have a look at another parameter of this, which is the global parameter. Now the global parameter can be found not in the callback here, but rather in the invoke node here. You see global. So when I press global, you see it actually removes that self target because we're not targeting anything specifically. It means that anything that has that shape hit callback will now be invoked. So for example, let's bring our triangle back. All right. And so we do this, 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 this. So we have a bunch of triangles on the screen, and let's say shape hit, and I'll change the color of these to be the color that's coming through. All right, let's just duplicate this again so we have the same flow. We're not going to make an asset at this point. Just do that. All right. So now when this hits this object, it sent out a global signal, which was intercepted by everything that has that signal callback for shape hit. All right. So now let's have a look at custom events. So you can create a custom event by typing in custom event, and you see the custom event can be of different types. Let's just make a basic one for now. So with custom events, these have a specific hard-coded name. So for example, let's do the same thing, shape hit. And this has the same as a signal callback, single target and multiple target. So the difference between a signal and a custom event is that, let's do a new custom event of a specific type, a custom event of, let's say, color. So a custom event can only actually have one value coming through. Everything else is very similar. You see, the event name in this case is hard-coded in, whereas in this case, it's an asset reference. But the single target, multiple targets, and the explicit target override are exactly the same. All right, so we can do this. And let me just disconnect this one for now. Okay, so we've got our custom event shape hit. So here we're going to send the event. Make sure it's of type T. Right click, change the generic type. And here we're going to find color. So this way we can still keep it typed nicely. It only supports one argument, but we can keep it typed so that there's less chance of us making an error. So there we go. Let's make it yellow or lime green. There we go. And we want to send it to our other. And here it's going to be called the shape hit. That's the name of our event that we have created in here. So now if we play, we see our circle sends the event called shape hit, and our square receives that. And that works nicely. Now, in order to do a global event, instead of being a setting here, because as you remember, the setting was actually in the invoke over here. So instead of it being here, it's actually a separate node. So send global event. All right, and that works exactly the same as a global signal, but we are basically putting in our own hard-coded event name, and we only support one argument. So events can be nice when you don't want to clutter your project with a lot of these, because as you can imagine, a lot of signal definitions being created could make it quite confusing or quite difficult for you to see through things, to figure out which ones you want to use. Usually I would say reserving the signal definitions for more complex behavior or behavior that's shared amongst different objects, right? Because for example here, where I have my square, and the behavior when the ball hits is that it changes color. I might actually want a different one. So let's create this one, and let's hook back up that signal. And in this case, instead of setting color, I actually want to set this object inactive. There we go, like that. So this will fall down, invoke from our collision 2D, our shape hit signal, which will, for this one, set it to be inactive, and for this one, set its color to be the lime green. And there we go. So you can imagine this is very useful for certain behaviors, such as if you were to attack certain enemies, maybe they have different reactions to it. Or if you were to interact with different objects, they have different behavior that can happen. All right, so the next thing that I want to go over is how to use a Unity event. So when we press the spacebar and we go into here, Events, Custom, you can actually see, instead of just custom events, we have Unity event callbacks. C# event callbacks, and delegate callbacks. So let's look at Unity event callbacks. So I can create this, and it's expecting a Unity event to go into here. So where do we get Unity events? Well, we can get it from scripts that we've made, or from existing scripts or components that exist in Unity that use the Unity event callback type. So for example, we can create a UI slider. There we go. So we've got the slider here. And when we play, I can go back and forth like this, and you see how the value gets updated here, right? So every time that value gets updated, this onValueChanged event gets sent off. And we can actually intercept that. So right now I'm inside my circle, but let's make a new one. So let's just make a new let's make a new circle over here. Let's just turn these off for now. All right, and I want to change the color of this circle depending on what that slider value is. So let me just create a FlowScript controller, a new bound graph, and now if I drag that slider in to here, and I look at events, you see I have this onValueChanged, and there's auto subscribe or onValueChanged get reference. Okay, so if I choose auto subscribe, that means that when the graph is enabled, it's going to subscribe this to the slider event, and when the graph is disabled, it's going to unsubscribe. Okay, now if we don't use this auto subscribe and we rather use the get reference, then I can create a Unity event callback like this. I can plug that in there, and I can choose to register or unregister. So maybe on enable, I want to register that callback, and on disable, I want to unregister. So this is the most common pattern that we usually use. However, since it's so common, we already have it basically automatically doing it for us here, right? And you can also do that here by clicking auto handle registration. But there may be some more complex cases where you want to be more manual with when you register and unregister. But in this case, we're just going to use the auto one. And so we can use either of these basically. They're essentially the same thing. It's just that this one has the value exposed here. All right, let's use the simpler one like this. Okay, and that's going to give us out a float. And so what I want to do is I want to lerp. So color lerp. And that's going to be our delta in there. And we can lerp between, let's say, red and blue. And we need to assign it. So let's grab our sprite renderer, set color, pass that new color in there. There we go. And now when we play, there you go. You can see our event callback gets called from our slider here as this changes. So that's pretty straightforward. And of course, this doesn't just work for existing components. We can also create our own. So we could create a new script, add the script to the circle. All right, and here we can just create a Unity event. We can pass through whatever we want. We can actually pass in 4 different types. So let's say we want a color, a float, an integer, and a game object. And let's call it on space pressed. Make sure it's public. And then here, if input.getKey down keycode.space, then on space pressed.invoke. And we're going to pass in color.red 0.5, 32, and this dot game object. There we go. And obviously, what we would actually do is pass through values that matter based on the context of what we're doing. But in this case, we're just going to pass through these values. All right, so now in here, I can drag my test script directly into here. go to events, and I have the exact same thing here that I had for the slider. So we'll do the auto subscribe on space pressed, and here we go. We actually get all these through. So we'll just connect that up, put that color through there, and maybe just log text. All right. And if we play, when we press space, it turns red and it logs out these values for us. And our slider still works as well. Cool, so that's really good. This is really powerful for when you have existing, like a nice existing code base with a lot of nice behavior that already exists, and you just want to hook it up to the flow graph and receive events that happen. All right, and now let's have a look at the C# events. So back in events, custom event, C# event callback. So here, instead of looking for a Unity event, we're looking for a C# event. So let's create one here. So we'll create an action, and you can see here how many different parameters we can put in here. It's actually more than the Unity event. So let's just do a color game object and a vector 3 like that. And let's say on enter pressed. Add the code here, so it's return. Yeah, so let's just rename this to be on return pressed, just to be the same. So on return pressed, we're going to invoke this here. And we're going to pass in color.cyan, this.gameObject, and a new vector 3, 3, and 4, something like that. All right, and very important, we do need to add the event keyword here. We drag our script in, we look at events, and you can see here, we have on return pressed, auto subscribe, and get reference. And you also see here, we also have these standard subscribe and unsubscribe syntaxes here. We're not going to use these, and we're going to use the auto subscribe, and there we go. We have our nice C# event here with our parameters here, our game object and our vector 3. And when we press return, there we go. So yeah, this is great. Unity events and standard C# events are both supported, so it's very easy to hook up your flow graphs to listen in on any events that you have going around your game already. It's a really nice way to integrate flow graph with your existing code base. All right, and the last one I want to look at is the delegate event type. So I'm going to create another circle. All right, and I want this circle to call a function on this circle here. Let's create some flow script controllers. All right, and let's create a custom function here. And what I want this custom function to do is I want it to set the color of myself to be red, and then I want it to wait for 3 seconds. Well, let's do 2 seconds. And then I want to set the color of myself to blue. All right. And then make sure, because it's a function that we're returning, and actually I want to return a value. So let's make a return type of float. And actually let's randomize this here. So let's get a random range. And we're going to wait between 1 and 3 seconds. And we're going to write this into a flow parameter called time weighted. Like that. And we need to read the flow parameter as well. There we go, time weighted. And then at the end of this, I'll read that value and feed that into the return like that. So we're going to return that value, but that value is only going to be returned after this wait is finished. I'll make sure that's connected up to there, to the time. And here, instead of start, we need to make sure it's on finish, like that. Which means that here, where we call that function, so let's drag this in here, flow script controller, methods, call function, and we're going to use call function async. And let's just tie it to our key down, like that. So when we put the key down, we want to call this function async. And when that function is completed, we want to log that time here. So if I put it in here, it means that it will call the function async and immediately log text. and we don't have access to that text, right? Which is not great. So instead, what I'm going to do is I'm going to use a delegate callback. So we go back into here, events, custom delegate callback, pass that into there like that. Then feed that into there. And now that is going to be our return. All right, make sure that we add the name of our function. So if we go here, it was called my function. So let's just say, let's call it change color. There we go, change color. No arguments, so that's fine. So when I press space, you see it goes here, it's waiting, and it goes out, and it logs. And if we look at our first circle, it goes in here, and there we go. So this is super powerful for being able to call functions async and have them return their value. So hopefully this helps you understand more about how to communicate between different flow graphs using various methods, various different event types. This is super powerful. You can hopefully now confidently link between not only flow graphs themselves, but also your C# code.